So researchers conducted a study to determine whether there were significant differences in graduation rates between medical students admitted through special programs and medical students admitted through the regular admissions criteria. It was found that the graduation rate was 97% for the medical students admitted through the special programs in all medical schools. Complete parts A and B. So I'm going to help you out with part A. Again, we need to go through the conditions for a binomial. Make sure you're mentally going through those. We've talked about these quite a bit. Another tip that is binomial, not to be Captain Obvious, but you're in a whole section on binomials. So that also helps you, but sort of go through the rationale of why it is binomial. So I'm going to use StatCrunch, and then I will turn to the TI just to show you another one on how to use TI. So stat calculators, binomial. So it said n was 9, and the probability was 0.97 that they made it through, and we said, or it asked for at least 8, right? So at least 8. So at least 8 is this one here, 8 and 9. So 0.97, I didn't catch the rounding, hold on. It said 3 decimals, so 0.972. And I'm going to let you think about part B. Let me show you how to do this on the TI. So on the TI, you got to think a little bit more. There are two ways to do it. You can either do the binomial PDF for 8 and 9, because remember we're looking for the probability that we get at least 8. So 8, probably at least 8 is 8 or 9. So you could do binomial PDF on 8, add that to binomial PDF at 9, and you're done. Another way to do it is to use the binomial CDF function. The C stands for cumulative, and with the cumulative, it will sum up from 0 all the way up to whatever number you tell it. So for instance, we can have the number 0, 1, okay, made that a little bigger for you. So we can go from 0 to 9. And when we use the binomial PDF, or sorry, CDF, the syntax is n, comma p, comma x. Go ahead and get there. So binomial, I'm going to go to second vars to access the distribution menu, and go down to binomial CDF. So trials is 9. P, I think it was 0.97. Yes, so 0.97. Now the x value, if it said at most 8, so 8 or fewer, we'd put an 8 in there, and it would sum up 0, 1, 2, 3, 4, 5, 6, 7, and 8. But it didn't say at most 8. It said at least 8, so at least 8 means 8 or more. So what we want is 8 or more. We want 8 and 9. Now notice what we can find. If I know this probability from 0 to 7, whatever it is, I can easily find 8 and 9 by subtracting from 1, because we know that this, when I add up all these to be a probability distribution, must sum to 1. So if I know from 0 to 7, I can take that, subtract it from 1, and I would have 8 to 9. So what I'm going to find is the x value here at 7. Okay, and I get 0.028. So the sum from 0 to 7 is 0.028. How do I find 8 and 9? I say 1 minus that. So I can say 1 minus, press second negative to get the ands, the last thing that it popped up, and we get 0.972. So again, we did 1 minus 0.028 to get 0.972. Be nice if TI had upper bound, lower bound. This particular version does not. I know there are some out there that do, but most students don't have those. So this is a workaround for that. Now, for this one, is only two values. You could have done binomial PDF with 8 plus binomial PDF with 9. There are also some other little slick ways you can do these. I leave that up to you to kind of Google around and find those if you want to, but those are the two basic ways. For me, I would do StatCrunch. Much easier, much more intuitive than using the TI. But if all you have is the TI, feel free to use that. I hope that helps.